Welcome technicians. Today we look into how to give samples to our hematology instrument. So first and the foremost thing, we have to ensure that the instrument is in ready status. So by looking at this caption here, we will know that the instrument is ready. And also we have to look into anything here has become red. So important thing is the system, it should not be red. Quality control, sometimes it does become red. Communication may show red, but still the instrument will keep working. Reagent, if the reagent window is little bit lesser, then also it may show be red. So important thing is the system should never be red. If the system is red, usually it indicates that the instrument is not ready to run. Okay, so first and the foremost thing, it is the main screen should be there and it is in the ready status, and we click in this button. Okay, now there are two ways by which we can give samples to this instrument. One is by this batch. So at a time 10, 20, 30, 40 like that samples we can give by this batch method, and another is by stat method. This is by giving the stat method. Now when the problem what we have faced with the batch method is when we give in batches, interfacing of the result doesn't happen. Because of that reason, we don't use batch method as a routine. So we normally run everything in the stat method only. So when you click on this button, immediately this is the window that appears. So in this window, we have to give the sample ID. So sample ID is usually on the vacutainer. In the barcode, it will be written like 2400253112 like that. So that will be, so you can easily read this sample ID by the barcode reader. Then in the sample comments, you have to write your name, the person who is actually running the sample, and in the last name you have to write the patient name. So once you write that, you have to click on this. Now few things I will make it very clear now itself. So as you can see, this is the instrument, and the stat all the samples which you are giving singly is always given through this area. Okay, so the batch is given from this part, that is on the right side of the when we stand on the right side. So this is the place from where the all the batch reagent samples are given, and this is the area in which stat samples are given, means single samples we can give from this area. Now when you look at it from the top, see it has got four places which can be utilized to put the vacutainers. Now we have not enabled these two positions, so this area we should not keep anything in this part. Now these two areas we have enabled. Now this is the area in which we should put vacutainer and give it to the instrument. Now let us say that for some reason, if the sample is very less, or amount of sample cannot be given through vacutainer or something, so we may have to give it in a bullet vial. Now recently we are starting microtainer, so even if the microtainers have come, so microtainers also we have to keep it here. Now when you keep it here, you need to make sure that it is rotated. Okay, because this steel vertical thing that is present, that is the area in which the needle will come and collect the sample. If you have kept it on this side and allow it to go, then the instrument is going to get stuck. So only this steel rack that is present, only in this area only the needle is going to work. So if you are keeping a bullet cup or a microtainer, you need to rotate it. So you need to rotate it and make it come here. Now why this is very important is because when you do that, the instrument will read the barcode on this edge. Okay, by this it will know what type of sample collection device is given to the instrument. So by that it will also know how much the needle has to go inside. Now if you don't if it is reading is wrong, what is going to happen is either the needle may break the vacutainer or it may break the bullet cup. So that is the reason why you need to make it is rotated. This is important. Now why I am repeatedly telling this point is because every now and then we have seen that if the technicians is not alert, the newly joined staff or the some of the internees who have come, they have done this mistake and the instrument gets stuck. And once the instrument gets stuck, it will take at least 20 to 25 minutes to correct the instrument and make it proper to work it again. Okay, so please make sure about this part. So if it is a microtainer or a bullet cup, it will be kept at this position and it has to be rotated, and so that it will come and sit here. okay, so that the barcode can be read. And not only that, if you are keeping, see, many times we have seen that when the vacutainer has been put with barcode, the barcode is not sticking properly to the vacutainer. So because of that reason, when the vacutainer is put, the vacutainer height may be above this steel rack. Okay, so if it is above that, again that is a problem. Okay, if let us say that you have put a bullet file and bullet file has not sitting properly into this hole, again it may be on the heights. Now that is also again a problem because of this barcode problem. Okay, so when you have to ensure that your the vacutainer is properly sitting below this level, or the bullet cup is sitting below this level. So see, I have shown here, this is a quality control vacutainer which I have kept, so it should be below this level. Now you may, the reason why you see this length through this length, well, most of the times if there is a height is more, it may get stuck here only, but if it is not, even then inside there is a plate through which the vacutainers are raised, and during that time only the instrument will get stuck, and it will make a horrible noise also, as if the whole instrument has broken down like that. So it's very important that the height is always below. Okay, so the good practice goes something like this. So what you do, you enter the patient name, your name on it, and then the last name, then you give yes. So it will come this, so it will tell that please mix. Now please do remember, whenever we are giving a sample in a stat mode, it's very important that manually we mix the vacutainer properly. So at least 10 times you should invert the vacutainer so that it gets mixed properly. Then only you keep and you validate it. Once you validate it, it will go in the this vacutainer holder will go into the instrument. The needle will collect the sample and do the testing. Okay, now why this is a good practice is because, see, you have entered these values, you have entered everything. Let us say that the instrument was idle for the last 45 minutes or something. Suddenly what happens when you give here auto clean option comes. Okay, auto cleaning means it is known that for a long time the pipes were all empty, so it will try to fill it before actually taking the sample. Now that another 2-3 minutes. During that time you would have kept the vacutainers here, which is idle now. So what happens, all the platelets would have settled down, and now when the reading comes, the platelet value, hemoglobin value will all come high. So because of that reason, whenever auto clean comes, so when you give the sample, you have to lift the vacutainer back, mix it well, and then keep it, and then you validate. Once you validate, it will go inside, and within 1 minute the values will come like this, and you can see the values. Now when you see these values, as we have already discussed, you have to check what is the total count. If the total count is above 20,000, you have to make a smear. If the platelets are below 1,50,000, you should make a smear, or if it is above 5 lakhs, you should make a smear. If the differential count neutrophils is above 80%, or lymphocyte is above 55%, or eosinophil is above 10%. So for all this, you can look at the chart that is been pasted next to our instrument, and based on that you have to make a smear and inform. Okay, it's important that you inform. Okay, so I hope you are able to understand how to give the vacutainer samples to the instrument. Thank you.